Hi friends, this is Rakesh from. Today we are going to discuss about whether a number is an Armstrong number or not. So before writing a program further, first we need to understand the logic of an Armstrong number. Uh, a number is Armstrong only if it's a positive number, and then it should satisfy the following conditions. So in case of Armstrong number of 3 digits, the sum of cubes of each digit is equal to number itself. For example, 153. Here 1 into 1 into 1 plus 5 into 5 into 5 plus 3 into 2 into 3 into 3 will give 153 as a total value. So if the total value and the input is same is, then it's an Armstrong number. For other digits, for example 4 digit or 5 digit, what we need to do is first we need to find the total number of digits that are present in that number. Here 1634, so total number of digits is 4. So 4 times we need to self multiply the number. So 1 into 1 into 1 into 1 plus 6 into 6 into 6 into 6 plus 3 into 3 into 3 into 3 plus 4 into 4 into 4 into 4. The final value should be equal to the initial value. If that's the case, then it's an Armstrong. Otherwise, it's not an Armstrong. So this is the mathematical logic. So programmatically, we can do this using some arithmetic operations. So first step what we need to do is we need to find the total number of digits that are present in that number. For example, 153 means the total number of digits is 3, whereas 1634 means the total number of digits is 4. So for that we need to use this divide operation rule to find the total number of digits. For example, 153 could please try to guess the logic how to find the total number of digits 1 in 153. If we give 1634, it should return 4. If we give 154748, it should return 5. There could be n number of logics to find the total number of digits, but this is the best or better logic to find the number of digits. For that, what you need to do is you need to divide that number by 10. So 153 divided by 10 will return quotient as 15 and remainder as 3. And then you need to reiterate the same operation using the latest quotient value. So 15. So 15 divided by 10, it will return quotient 1, remainder 5. So the latest quotient is 1. So 1 divided by 10, quotient 0 and remainder 1. When the quotient becomes 0, then you should stop the iteration and you need to count the total number of iterations happened. Here 1, 2, 3. So the total number of iterations equal to the total number of digits. So here we are trying to implement the same thing. First we are trying to copy the number to the clone number variable, and then we are trying to implement this logic using code fragment. Equal to cloned bird by 10 and int total digits equal to 0, total digits plus plus. So here if suppose 153 greater than 0, 153 equal to 153 divided by 10, the quotient would be 15. That would be used for the next iteration. Total digits would be increased from 0 to 1. 15 greater than 0, 15 divided by 10, the quotient is 1, so 1 would be stored in cloned number. Total digits would be increased from 1 to 2. Then 1 greater than 0, 1 divided by 10, 1 divided by 10 would return 0 as the quotient. That would be stored in clone number. Total digits would be increased from 2 to 3. 1 greater than 0, 1 divided by 10, the clone number equal to 0. So finally the total number of digits would be 3. And then second step is we need to multiply each index value using for total digits times. For example, 153, here the total number of digits is 3, so we need to multiply 3 times of the same we need to self multiply 3 times. So 1 into 1 into 1, 5 into 5 into 5, 3 into 3 into 3. For doing that, we need to find for 153, we need to find the remainder value of, we need to get the remainder value 3, and then using the latest quotient and remainder, we need to get the another remainder 3, 5, and then 1. So the iteration would 1 would return 153 divided by 10, the remainder would be 3, quotient 15. We need to multiply 3 into 3 times. So 3 into 3 into 3, it would return 27. Using the latest quotient value, we need to divide it by 10 once again. It would return remainder 5 and quotient 1. So we need to do the multiplication operation, 5 into 5 into 5, and then we need to add with the previous 3 into 3 into 3 value. Using the latest quotient value, we need to do the division operation, 1 divided by 10. So 1 into 1 into 1 using the remainder value, and then we need to add with the previous 5 into 5 into 5 and 3 into 3 into 3, and the latest quotient will be 0. So we need to stop whenever the quotient becomes 0. So this is the logic. We can implement this logic in a simple manner. So clone number, so first what we are trying to do is we are trying to get the remainder, clone the number equal to remainder operation of 10. So it would return 153, the remainder would be 3. So and then what we need to do is we need to store that value in the total value equal to 0. So total value equal to total value plus math dot power remainder and total digits. Since we could return in the double format, we need to we need to typecast that. And then what we need to do is we need to clone number equal to cloned number divided by 10. So what it would do is, first initially the number would be 153 greater than 0. So remainder of 153 is 3. So 3 into 3 into 3, it would be stored in total value, and then 153 divided by 10 would be 15. So 15 greater than 0. So 15 remainder operation 10 would be 5. 5 into 5 into 5 plus 3 into 3 into 3 would be stored in total value. That is 1. Previously 3 into 3 into 3 equal to 27. Now the latest value 5 into 5 into 5 equal to 125. The total value 152 would be stored in total value, and the clone value would be become 115 divided by 10 is 1 would be stored in cloned number. So 1 greater than 0. So 1 remainder operation 10 would return 1. So total value equal to 152, which means the previous total value plus 1 into 1 into 1, which is 1. So the total value would be 153. So finally 1 divided by 10 equal to 0. The clone number would be 0. Clone number 0 greater than 0 false. And then what we need to do is we need to check if total value equal to number Armstrong, else not an Armstrong. That's it. So if you run this program, we can give any number, 1 equal to 1 Armstrong, and then 153 is an Armstrong. If we can check with the 4-digit number also, 1634 Armstrong, and we can also check with the 5-digit number also. If suppose if we give any number which is not an Armstrong, it will display it's not an Armstrong. So that's a simple program. This is the simplest program by which we can check whether number is an Armstrong or not. So if suppose if you have any doubt, please try to comment those queries in the comment box so that I can explain it in a better manner. So thanks for watching this.